There's really two benefits. One is the main benefit on the system administrator side or the IT administrator side in the sense of setting up the servers. There's one cable or one wire, maybe two wires coming out of a box. It's easy to track which machine is plugged into which switch. It's easy to keep track of all these things. The number of wires in a data center goes down drastically. It looks a lot cleaner. It's just a lot easier to maintain. Now, basically on the software side, from an Oracle point of view, what's interesting here is that we're very much into clustering, and part of clustering means that when a system within a cluster misbehaves, we have to be able to shut that down because it could wake up again suddenly and do an I/O to storage, which would then cause data corruption and so forth. And so what we can do with fewer wires is we can disable one port and basically totally isolate that one machine from the cluster, from the network, from the storage. Virtualization started, a few years ago where it became really serious and important to customers. And the main driver that we have seen is obviously consolidation. There is the agility of using virtualization where you can move a virtual machine from one server to the other without downtime and the ease of management. But really, the most critical part that we've seen so far has been the ability to consolidate servers onto fewer machines. And even within Oracle, in our own data center, we have thousands and thousands of machines, and many of those run at 10–15% utilization. So virtualization allows us to take 4 machines, 5 machines, and consolidate this down to a single physical server. And as part of that, we built Oracle VM and released Oracle VM as a product, which is the only solution that we support for the Oracle product stack on top of Linux, on top of a hypervisor, where we do full certification and support for all the products. Data integrity is a very exciting product or a feature set. I think it allows us to make Linux be totally different from every other operating system. It allows us to do stuff which we traditionally could only do with the very high-end, very expensive storage arrays, and even at that with very limited usability. So basically what happens today is that when a database writes a block to disk, then one of many things can happen. One is the disk can give an I/O error back, and Oracle can easily recover from I/O errors. We can easily recover from system crashes. It takes a matter of a few seconds, and the system's back up and running. However, the more difficult ones are silent corruptions. So the database sends an I/O, maybe 8 kilobyte of data to disk. It goes through the kernel and the operating system. It goes through the storage adapter to the switch over the wire to the disk array. And if a data corruption happens there without us knowing, it doesn't show immediately. It can show 6 months later. It can show a year later. And recovering from these situations can take very long. You have to go back to backup. You have to restore from tape. You have to even have that backup. And so the actual amount of downtime is very long. And it's very costly for any customer running into this. The data integrity project that we're working on is going to avoid this from happening because the database makes a checksum. The checksum goes down to the kernel. The storage adapter does the checksum. It goes down the wire along to the disks eventually. And so there is no chance of an actual silent corruption anymore. We will get an I/O error back if something happens, but as I said, we can easily recover from that. So we are now able to do this in low-cost servers on standard off-the-shelf, basically 1U, 2U environments with Emulex adapters.